Hi, my name is Angela Mitchell, and today I'm going to be talking to you about the energy systems, what they are, and how they work. So, there are three main energy systems. There's the ATP-PCR system, or the phosphagen system. Number two, the glycolic system, and then we have the oxidative system. So first, let's start with the ATP-PCR system, or the phosphagen system. This system is the very fast moving system, I would say. So, basically anything that's within 0 to 10 seconds, very short period of time. It's like, for here I have a basketball player doing tip-off. So it's that very fast motion, and that's where the phosphagen energy system comes into play. The main fuel source is ATP and creatine, just for that fast, basically whenever you're working out or just starting to work out, this is what gives you energy first, and what taps into that ATP storage first. And then, for an example, I put jumping, or for the tip off for baseball, and then for basketball, and then for football, you could say when a quarterback throws the ball, it's that very fast motion, 0 to 10 second range of movement and energy expenditure. Next, we have the glycolic system. So this system is a little bit longer. It goes from 10 to 2 minutes period of time. And for here, I put the 400 meter sprint. So this is something that is still fast. You're still using that energy that you have, but this is right after that 10-second mark, where we're done using the phosphagen system, and now we're using this glycolic system, and using this for our energy fuel. And then for actual fuel source, this is we use carbohydrates, and then it forms into in our body a lactate, but basically it's our carbohydrates are our main source, breaks it down to glucose, hence glycolic. But yes, so then, and this is no oxygen. So this is both the ATP, phosphagen, and the I can't say it anymore. Glycolytic systems do not use oxygen. So there's that. And then next we have the oxidative system. So this one, obviously, hence the name oxidative, uses oxygen. So it's aerobic system, and this is the long, steady. So I have fourth quarter here. So this is like when during a game, this is the energy that you will be using to withhold that whole time of playing, or just using your energy. So I put an example, like running a marathon. You can't just rely on that 10-second first one, or that 10 to 2 minutes. It's gonna be hours and hours long. So the time for this is about 2 minutes to hours of energy, or of time for that energy expenditure. And then for fuel source, so our carbs and fats. With this one, so our carbs, obviously, main source of glucose, breakdown, goes into ATP, becomes that, and then that whole cycle. But for the fats, this is really important because fats break down slower. So it really helps maintain that steady release of energy through running, or running a long distance, versus that 40 or 400 meter sprint where you're running really fast for a short period of time, where you can just rely on the carbs for that. For this, fats are needed for that slow energy production. Okay, so then that's that. And then, okay, so energy ladder, system ladder. So this kind of puts everything together and kind of shows you on a scale. I've kind of been explaining how they kind of go hand in hand, but this just really helps to clarify that. So basically, the main point of an energy system ladder is that duration pushes you down the ladder and intensity pushes you up the ladder. So what does that mean? So duration is the time, obviously. That pushes you down the ladder. The intensity, so how fast are we going? How much energy are we actually using? That pushes you up the ladder. So for the first energy system that we went over, which is the ATP PCR system, that is that short, explosive, really fast, high intensity. Like you're basically maxing intensity from 0 to 10 seconds. Like you're putting out everything that you have. And that's where you're going to be at the very top of that ladder. The middle of that ladder is that glycolytic system, where it's that medium intensity. You're still going. Like it's still pretty intensive, because it is 10 to 2 minutes of just fully, like for the 400 meter sprint, you are sprinting. You are in a dead sprint and you're using up all that energy, but it's not as much energy as it would be if you were doing that max level, that jump, that like really high, short amount of time, lots of energy. And this one tends to be more explosive, more like, because running, you can start off really explosive, and then that's where it starts off here, and then it kind of goes down to this, and you kind of see that ladder effect where it goes, okay, we start here, we go there. And then at the bottom, we have the oxidative system, because this is that lower intensity. Again, low intensity doesn't necessarily mean you're not putting in effort. It just means that there's more effort that you have stored, I guess, like in the tank, you could say, that you're just not using for these specific sports, because if you did, you wouldn't be able to execute what you're trying to do. Like for a marathon, as an example, you would not be able to use the top of the ladder, explosives, whatever, because you won't be able to finish the race. You have to use that oxidative system, low ladder, long endurance, or long duration time, because it's like a 2-4 hour race, depending on how fast you are. And so it can be intensive, but it's not super like fast, quick, long. So, but basically at the end of the day, it's the longer the duration, pushes you down the ladder. And then the more the intensity, it pushes you up the ladder. All right. So next. So MET levels and caloric burn. So the main point to this, so what is an MET level? So this is your metabolic equivalent of task. So what does that mean? It means that you, like, the more energy and activity takes, like, what is that compared to your rest time, or what it would take if you were resting. So basically it just compares both of those things. So exactly saying it measures how much energy and activity takes versus the energy it takes taken to rest. So it just kind of compares the two, and it makes it so you can kind of figure out, like, okay, how much energy am I actually expending, and like what is it for, and this can be different for each person. So for instance, like one MET is sitting at rest. you're not really doing anything. You're sitting, you're at rest. You might be moving a little bit, but it's not going to be that like high level rate. And then for what does this have to do with calories burned? So the more higher the intensity is, the more calories you burn, which makes sense because obviously, like, when you're using these energy systems, the energy systems aren't going to work if they don't have fuel, if they don't have those carbohydrates, those fats, and I talked about how important fats are, for example, for your oxidative process. Like, you're not going to be able to just rely on carbohydrates for that. So at the end of the day, it's, you have to be eating, you have to be making sure that you're just taking in as at least as much as you're putting out. So this can be a really great way to measure, like, okay, so I know that this is intensity for me, so I'm going to eat this many calories, so because they're both equal to each other. So you can kind of have that help guide you through gaining that muscle, gaining strength, and being able to complete your sport. So that's all that I have for today. And then obviously sources from our textbook, Kenny, Sports Exercise Physiology. Thank you so much. Bye.